All right, well, thank you so much for coming here and welcoming me and giving me a chance to talk about this. It's the first time I've given this talk, which always scares me for a variety of different reasons. It could go for 15 minutes. It could go for 50 minutes. We'll see how it goes. And then also, hopefully, we'll have time for questions at the end. So put those in Slack or keep them in your head. Also, this clicker, you press down to go forward, which is still messing with my head, but I'm working on it. Maybe. It worked when I did this before. All right. This is starting out really well. Now it's working. All right, cool. All right, so the fine print. I'm not really an AI person. I've done AI at various times throughout my career. I'm old enough that I learned about some very, very ancient, not even really AI techniques, or really old AI techniques when I was studying it in graduate school. And I've sort of dabbled in AI here and there. But I'm really not, like the AI expert. And I would also say that this field moves incredibly fast, right? So this represents work that we started about 18 months ago, give or take, and have brought into preview and are headed towards general availability very soon. And so it could be that the things I'm going to talk about are all ancient history at this point, so apologies in advance. I also have no idea. I was thinking about this a little bit as I was preparing for this talk. I actually have no idea what the general level of AI usage is for most SREs these days. And so I'm curious, actually, if I could just get a raise of hands real quickly. How many of you have AI involved in your product that you support? All right, I'm guessing that's 10, 15, 20%. All right, so some of this, I apologize in advance. Maybe this is all stuff that you've already gone through and talked about. This is all stuff that you already know. Hopefully there's some entertaining or at least educational pieces to the whole thing that you can take away. And for those of you who haven't thought about this before, hopefully it will inspire you. The other piece of this is this really represents a lot of work that was not done by me. I have a great team that was responsible for developing the Microsoft Azure Copilot, which is part of the Azure portal. They did all of the hard work. They learned a lot of the lessons. And so I'm also want to really acknowledge that I'm up here representing the work of a lot of other people. And I'm grateful for that opportunity. All right, so I wanted to give a brief overview of what the Microsoft Copilot in Azure is. That is the official. I had to prevent them from putting Pro Edition on the end. But that is the official name for this product. It went through a number of iterations as we standardized. I wanted to start out by talking about the fact that the team that built this, and I don't think this is unusual, much like I said myself, I don't have that much of a background in AI. The team that built this Copilot didn't have any background in AI either, right? They were the web front-end team. They had a lot of experience in front-end development, in client user experiences, in delivering things out to an end user that were useful, but they didn't have a lot of experience in AI. And I think that's really instructive because I think one of the things that we're seeing as AI has swept through all of the products that we're supporting is that a lot of times, because it's a simple API call to call into OpenAI on Azure or OpenAI or at ChatGPT or wherever else you happen to be doing your AI, a lot of people are starting to integrate AI into their products without having a particularly deep understanding of what's going on. And I think that has implications for what happens when we stop with the integration into the product part and we start into the let's keep it running and maybe it's successful and let's try and keep it successful part. And so those learnings are what I'm trying to capture here. I was going to have a really great demo of the Azure Copilot. But this morning, I was putting this slide, finishing touches on the plane on the way down. Network wasn't very strong. This morning, I flipped open my laptop to put in the video for the demo. And this is what my device said to me, which is kind of a new thing for me. It's the first time that a demo has actually, and the demo gods have come after me before I was even up on stage. But I wanted to actually give you a sense. So I'm going to give a live demo, which is, even more exciting. Oh, I know, right? Woo! All right. So hopefully this will work. One of the other times that I conference Wi-Fi'd. I got conference Wi-Fi'd. There we go. All right, it was SREcon25. I guess the hotel Wi-Fi does not reach down in here. One time when I was doing a live demo, I actually got two-factored, and my phone was like backstage. That was super exciting. I messed up the password somehow. SREcon2025. I think it is, although here, let's see. I'll show you the password. There you go. All right, cool. That's like a faux pas, right? I actually was tempted one time to have my pin be like circle, 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 circle. Oh, great. No, all right. Well, I'm just, woo, all right, yeah, all right, there you go. That's the demo for you. All right, the demo is hotel or conference Wi-Fi isn't good. All right, well, I encourage everybody to check it out if they get a chance. There we go. All right, I encourage everybody to check it out if they get a chance. I think at this point, everybody's pretty familiar with the idea of a Copilot. The one in the Azure portal is really intended to answer sort of operational questions. And so you can walk up to it and say, like, show me the list of the most expensive resources that I have, or give me some suggestions for how I might increase my zonal resiliency. Those kinds of questions. And it allows you to get really pretty deep insight from the query interface that we have into the backend systems through a chat-based interface. And I think, although I'm not going to go into it in very much detail, one of the other areas that AI and LLMs have really revolutionized how we do operations and life site and support of the products that we build has actually been in simplifying a lot of the introspection and investigation that you have to do in response to a pager. And so if you haven't been exploring that within your organizations, I strongly suggest checking it out, whether it's in Azure or any of the other clouds or on Kubernetes or anything else like that. There's a lot of really great solutions for chat-based interfacing to the data that is the operational parts of what we do. All right, at a high level, this is basically the way the Copilot works. We have the portal, we have user content, or context, that's like all the stuff, all the VMs or whatever that I have. We've got some domain-specific handlers, and then a foundation model. And it's actually really instructive to understand that we didn't do any fine-tuning here. This is all based on foundation models and the user's context being brought in through retrieval augmented generation. These are the lessons that we basically learned. The first one is AI is new stuff. If you didn't already know that, now you do. Then a lot about observability and debuggability, and also about reliability and testing. I wanted to start with the AI is new stuff part of the program. By the way, other pro tip is if you haven't started using AI to generate the pictures for your talks, you should start doing it today. Most of the images here were brought to you by AI. And I think the reason that it's interesting to think about AI being new stuff is not because it is something that all of a sudden everybody is talking about, but actually because it brings in some additional complexities that we haven't necessarily encountered before. And I think that is the part where we're still kind of reasoning through. There's still a lot of lack of deep understanding, I think, about what exactly it means. All right, the first thing that I wanted to say is that we are going through this transition from right and wrong to good and bad. Right? And I think that's a really important thing for everybody who does operations and reliability to think about. It's not about are you returning results without errors, or are you not returning, are you returning results with errors? That's obviously necessary, right? You don't want to return results, or you don't want to have your system returning errors all the time. Obviously, if it's returning errors, your system is down. But there's this added complexity that comes on top of it, which is, are you returning good answers? So it's not just are you returning answers, it's are you returning good answers? And that notion of good actually is now part of what it means to deliver a reliable system. And so we need to be able to actually be able to reason about what's good and what's bad, as opposed to just the binary, I return to 200, I return to 500. And I think that's the first piece that you need to wrap your head around. It has a lot of implications across a lot of these different systems. Another thing that's really relevant, this maybe is a little bit more obvious, but in these systems, the prompt, and really actually it's more the meta prompt, the stuff that you're putting around the prompt, is the code. right? And so the same things that you think about when you think about rolling out the software, you need to be thinking about when you're rolling out the prompt. And any changes there can have really big impact on the overall quality of the system that you're building. And so if you haven't dug into these systems about exactly how these chat-based systems work, maybe everybody knows at this point, but like the piece that you enter is like a tiny little chunk of what actually gets sent to the model. And the thing that surrounds what you typed in is a bunch of meta instructions about what you're doing and what you're trying to do. And that thing really shapes your experience, and that thing needs to be treated like code. And we'll go through the details of like how you think about rolling it out and all that kind of stuff. The whole point of the good and bad, versus right versus wrong is if you hadn't thought about statistics beyond sort of like the 99th percentile or whatever else it is that we were taught when we started thinking about latency, you need to go back and start thinking about statistics, right? Because the truth is that any change that you make in one of these systems isn't going to be universally good or universally bad. It's going to be probabilistically good or probabilistically bad. And being able to reason and understand about what it means to say like, well, we think that this change is probably better is important versus knowing for certain that this change is better, right? And the way that we do that is statistics. And then I think the last piece is that's really interesting to think about is that the users are confused about AI too. And we had some very, very disturbed users when we first rolled out the Azure Copilot who strongly believed that we had stolen their resource data, their VM data and all that sort of thing, and trained it into the model. And they wanted to understand why we had violated all of the nice things that we put out there about your privacy and things like that in order to develop this Copilot. And we had to sit down and explain to people, and I'm not even sure they still believed it at the end of the day, that with retrieval augmented generation, what you are doing is you're taking the user's context, adding in the prompt, and shoving it through a foundation model that knows nothing about anything except for foundational concepts. And that's how it displays information about their resources. But it took a lot of explaining, honestly. And so the users are confused about all of these models and how this AI stuff works too. And so you're going to have to be explaining to your product managers, to your developers, to your users, how this whole thing comes together. All right, so that's sort of like all of the new bits. Now we'll get into the meat of it, I think, hopefully from the reliability and delivering reliability perspective, which is, I guess, what we're all about here. The first thing is, this is like one of the most important monitoring signals you're going to use, right? So, and this is, I think, a really interesting change. As I said before, obviously, we're going to monitor all the same things. We're going to monitor, like, did we return results successfully? What's the latency? Like, none of that stuff changes, but it no longer says that your system is working right. And what is going to say whether your system is working right is the user's feedback. And the very first way of getting users' feedback, at least on our systems, and I think a lot of other systems, is to basically ask them, was this a good response? Was this a bad response? Right? And we did this, and we got a nice not clean, but we got a nice signal of like percentage of thumbs ups and percentage of thumbs down, and also obviously the percentage of people who don't click either, and that's an important thing to think about, because the majority of people don't click either. And then the next majority of people, they don't click thumbs up. They click thumbs down, right? And so early on, we were like, oh my God, we have built the worst product ever, right? Because our thumbs down to thumbs up ratio was like crazy high, right? And then you step back and you think about it, and you're like, okay, well, I'm a user, put myself in the user's shoes. I just entered a prompt. If I got what I'm looking for, most of the time, I just keep going. I just keep chatting, and I'm trying to accomplish something. But if you told me something stupid, or you hallucinated to me, I'm thumbs downing you like 100% of the time, right? Because I'm annoyed, and I kind of want to register my annoyance. And so it's worth remembering, again, going back to statistics, it's worth remembering that like the signal that you see, thumbs down versus thumbs up, is not actually necessarily the reality of the experience. And actually, the people who don't click thumbs down, it's probably okay, right? And so you can judge and guess, and I will say, be careful, because whenever there's an opportunity to assume that your thing is better than it is, people have a tendency to gravitate towards it. So make sure that you're sure that like the absence of a thumbs down is probably a thumbs up. But it's worth understanding the expected human behavior in that signal because it's no longer just a machine counting error codes. It's people. So we got this thumbs down, thumbs up signal. We were like, OK, we got to make it better. And then we realized we didn't know anything, right? Because we got the thumbs down, but for privacy reasons, we didn't get the chat. And it makes sense, right? Like the chat is you sharing your personal questions. It might be passwords. There's other kinds of stuff, the IP addresses. There's various things in there that we don't necessarily have the right to collect all the time. But it's really, really hard to know if you can sort of tell if you're doing a good or bad job, but if you want to make it better, which is the next step, right? You have to understand like where did it go off the rails in the first place. So you need that context, and you need that chat. And it's actually an interesting problem that a lot of us have faced in various circumstances, I think, of like, well, do you default it on, in which case you might have, if someone clicks feedback, do you default on the context? You have a little checkbox that says, you agree to share your conversation with whomever, and just send it with that checkbox defaulted on? Or do you default it off, in which case you're not going to get as much information, but you're going to respect people's privacy a little bit more? We chose to default it off, and it meant that we were flying pretty blind, especially early on. And I sort of overtalked this slide a little bit, but basically what it amounts to is most people will click the thumbs up, thumbs down button, or especially the thumbs down button, but very few people will share their conversations. And so that means if you want to figure out like why there's a problem, so we've gotten alerted, we think there is a problem, we need to figure out why there's a problem, it gets really, really tricky. So we thought about this for a little bit. And what we realized was that one of the ways that you can do this, obviously, is by turning on the default. But we're not comfortable turning on the default for everyone. But we were comfortable turning on the default for our internal users, right? And we figured that Microsoft is a big company. We get representative feedback from people who are there's 100,000, or actually more than that, users on the portal. That's a lot of feedback. And so with those conversations alone, we probably would get enough signal that we would be able to debug what's going on. And so that combination of being able to say, hey, in general, we're not going to collect people's chats, but in the context of a corporate user, corporate login, we will default. They can still check it off, but we're going to turn it on by default, enabled us to get enough signal, enough data to actually be able to debug things. Wrong button. All right. I wanted to talk a little bit about how we actually think about this, though, beyond what kind of metrics are we going to be collecting, not just the feedback and the context for the debugging, but how do we think about actually understanding how well our systems are doing. Obviously, the thumbs up, thumbs down is one thing that I talked about. But there's more sophisticated metrics that we can use that we have used in other contexts. I wanted to start by going over the fact that the old metrics that you use, that you maybe are used to, like latency, like error rate, like all of those sorts of things, they're still applicable. And we should still collect those. But they're not the only thing. And in fact, there's new metrics, and they look a lot less like measuring things and a lot more like social media that you need to be thinking about. And the first metric that we pay a lot of attention to is this idea of net satisfaction. And again, this isn't something that's rooted in AI. If you're doing a consumer-facing product, this may be something that you're already looking at. There's various ways of measuring customer satisfaction. This is a Microsoft-used one. There's other things you can use if you want. It's a 4-point score, very satisfied, somewhat dissatisfied, very dissatisfied, right? And so when you submit feedback, you get prompted and say, how do you feel about this? Or sometimes we randomly prompt you as well. You get to vote on this 4-point score, or 4-location score. And then we calculate this thing that we call NSAT. And NSAT is the percentage of very satisfied minus the percentage of somewhat dissatisfied plus very dissatisfied. And then you add 100 just to make it not a negative number. I don't really know why exactly, just because I guess people don't like negative numbers. Makes people feel bad, Teams with negative NSAT feel bad. But it gives you a score from 0 to 200. And this score, as you measure it over time or over different parts of the system or over different conversations, you'll get a signal that goes up and down. Right? And it basically represents how satisfied somebody is. Right? If 100% of people are fully satisfied, you're at 200. If everybody is dissatisfied, you're at 0. It's a good one. And then the other one is one that is not Microsoft specific that people may have seen also. It's called Net Promoter Score. And it basically says, let's divide the world into 3 categories. You have promoters, you have passives, and you have detractors. And you can decide where you want to cut those lines. Again, it's based on a survey or a 0 to 10 slider. You know, how happy are you? How likely are you to refer it to? If you ever see that, like that stupid survey that's like, how likely are you to refer somebody else to do this? They're probably calculating this behind the scenes. And basically, it's trying to measure, like, would you go and tell somebody they should use it? And so it says basically, how many promoters you have, or would you tell someone, oh, that thing was terrible, you shouldn't use it? It basically ignores the people in the middle, but it measures the people who are your friends versus the people who are your enemies, and it gives you this Net Promoter Score. And so these are the 2 signals that we use a lot of the time to understand that and the thumbs up, thumbs down, a lot of the time to see if we're doing a good job. Right? Thumbs up, thumbs down gives us a good sense of any individual conversation or any individual response. NSAT and Net Promoter Score give us a really good indication of whether or not, in general, people are liking the product, liking the experience of the AI. But there's important caveats. Early on, when I got started with doing some of this stuff, we saw a really, really big dip. I was like, what's going on? Like, did we release a bad prompt? Did we change the model? And the team was like, we have no idea what's going on, why it's dipping so hard. And then we figured out, because we looked back across history and we got the right event stream in there, Net Promoter Score always dips, and NSAT always dips when you have outages. Not our outages, by the way, other system outages, right? So if Azure has an outage, in general, some region has a network problem, or some service has another problem in a different region, or wherever it happens to be, the Net Promoter Score for the client tools takes a dip. Just because people are just a little bit grumpier, right? And like they get that survey in the portal, and they don't think like this survey is just about the web interface or just about the Copilot. They're just mad. And so they score you down, right? And so over history, when we looked back, we could actually see that there's a correlation between other activities of other teams and where these scores go. And suddenly we realized, like, okay, like we actually have to tease this apart and understand, like, is the dip in these scores our responsibility, or is it because of something in the global system that happened? I guess it's not that different from understanding, like, is this outage due to my system failing or some downstream dependency failing? But it's a lot fuzzier, right? And so I think this is the trouble, again, when you're starting to do AI and you're starting to think about the reliability of these systems that we're building. The thing I talked about at the beginning of like good versus bad versus right versus wrong, it really starts to become something you need to be reasoning about. And being able to look back and find those correlations and understand, like, okay, maybe we can actually compensate. So if we know there was an outage a week ago, we expect a 2-point dip in NPS, we'll bump up the current NPS scores by 2 points and see if it's in line with what we expected. Because we could have both. Right? We could have shipped something bad, and there could have been an outage, and we still want to be able to detect that. And we've seen other impacts as well. Certain browsers, certain operating systems, different things have happened where there's been correlations between things that we don't control and these scores. It's worth remembering and worth taking a look at and understanding. All right, so I wanted to shift from maintaining the reliability to how do we do change, the rollout part, right? So one of the most interesting things is that when you're starting to build these systems, it's actually very important, because they're so dependent on user information, it's really important to also have user information present in the development process. And And you need to be able to do experiments. This isn't a new concept, but the criticality of experiments when you're doing AI work, I think just becomes incredibly important because it's really not sufficient. All of us have biases, right? And so any individual developer, they're going to, as they make changes to the prompt, they're going to be tuning it to the things that they're interested in. Maybe they have a bug and they're working really hard to craft a new prompt or to do some sort of other tuning to fix that particular bug that they're working on. They don't have the broader context of, is it making the whole system better, or is it just making this one specific use case better, possibly at the expense of other use cases? And so this idea of using experiments and being able to run 99% of traffic through the existing prompt and then 1% of traffic through a prompt that the developer is working on becomes crucially important in terms of the initial development of these tools and of these systems, because there's just nothing like having production data flowing through the thing that you're working on in order to be able to see what's going on in the broad sense. This obviously brings in a lot of challenges. We're fortunate in the fact that the Azure portal had a pretty rich experimentation framework built into it already that we got to leverage. If you don't have an experimentation framework and you're thinking about AI, there's several out there. I definitely recommend you check one out. There's also a lot of things around making sure that you detect errors and shut off the experiments pretty quick if it turns out that the prompt is totally broken or something like that. But being able to get your developers out into the production stream of inputs is critically important. I think the other thing that's really valuable is this ability to actually figure out, before you really do the full rollout, is it actually working, right? Because a 1% experiment can sort of tell you it's a good idea. It won't do a great job of telling you, did you truly break something? And so in addition to doing these sorts of 1% experiments, we have architected the system so that we do a lot of testing out in production as well. And the way that we do this is through something that's probably, again, pretty commonly understood for everybody, but becomes, again, even more important in the world of AI, which is dogfooding our system, right? So if you log into the Azure portal inside of the Microsoft.com, or it's inside of the Microsoft, with a Microsoft.com corporate identity, you actually get put into the canary version of our portal. The URL doesn't change, so you don't actually notice, but you get all that traffic gets driven through the canary version of our portal, and we do rapid deployments out into that environment. That allows us, again, with a large company, the benefit of a large company doing a lot of different things means that we get a lot of representative traffic onto our canaries before they go anywhere beyond our own company. And obviously, if we break things, we're only breaking ourselves, not end users. That's a good thing to do. If we roll out a new model and it's bad or it's high latency, we'll catch that first. If we adjust the prompt and suddenly it starts returning more creative solutions than we would expect, we'll see that first. And so this is really valuable to have this architecture of being able to dog food automatically. But also, because there's still production things happening, we also had to supply a break glass. So we have the ability to say, oh, actually, we broke you, but you're trying to restore your system. Here's the break glass that'll get you back to our production so that we don't break you, while you're trying to actually get something done. And that's also an important part. You can't sort of have one without the other. I wanted to talk a little bit about how we think about qualifying a release. Because this is actually also a really interesting topic. Previously, you'd say, well, how do you qualify a release? Well, you run all the tests, and if it's green, you release it. In the world of AI prompts, you don't know necessarily. The thing is that every single change that you make is going to make some things better, but it's probably going to make some things worse. And what you need to be able to say is, on aggregate, I think that this thing makes things better, right? So we used to be able to write a unit test and say, does this use case work? Now you actually have to run maybe 1,000 prompts through the system to know, did it mostly make those prompts better or did it make those prompts worse? You can't just have one prompt because that's a binary signal. Either it's better or it's worse, and that's a pretty bad signal, right? You need to have a volume so that you get a probability, not a yes or no. The problem with that, of course, is you need to generate test cases. In order to generate test cases, you could sample data from the end users. It has some privacy challenges. The interesting thing is, in a lot of these problems, the LLM itself is the answer. And so what we did was we went in and we actually just asked the LLM to generate a bunch of test cases for us. Right? You can ask these systems, just say, like, give me 10,000 representative prompts. Imagine that you're an end user with this kind of infrastructure. Give me a prompt that represents what you might ask a Copilot about your or about your cloud infrastructure. And so you can generate all those test cases. So now we've got 10,000 test cases that we can run the system through as we're qualifying a release. Oops, that's the wrong button. But then you say, like, OK, well, great. Like, is this change good or bad? Right? Because the prompt is going to change every time. Or excuse me, the response is going to change every time. So you change the prompt, you change some code, you change the model, the response changes. So the computer, the only thing the computer can do is the computer can tell you it's different. This text is different than that text. That's not very useful. You need to know, is this text better or at least the same as what I had before? And so you could have humans look at those 10,000 cases if you wanted to really put a lot of toil on your people and have a very, very slow release pipeline. But you need to be able to figure out if the answer is good. And the interesting thing here is that, and sorry, I overtalked that slide. You need to figure out if the answer is good. And the interesting thing here is just as like generating the test cases, the large language model actually runs to the rescue for the evaluation as well. And so you can actually go back to the model and say, hey, given this prompt and this answer, do you think that's a good answer? And it will actually give you an answer, yes or no. And a lot of the time, it's actually right. And so that alone is enough to give you a signal about whether or not your tests are working correctly. Right? So if you combine these things together, where we have human input for the development, human evaluation in terms of thumbs up and thumbs down, automation in terms of release qualification, and then, again, human measurements once you're out into production to make sure, to catch any things that might have regressed through the test cases that you've done the qualification, you can actually start successfully rolling out things from development through testing all the way out into production. I think another thing that's really worth mentioning is that the models are part of the code too. And we need to do the same kind of 1% experiments. We actually saw some pretty significant regressions in places where other people said, wow, we went from model A to model B, and it was that much better, it was that much faster. We saw some problems sometimes. Sometimes you need to tweak the prompt. Sometimes you need to tweak the protection from hallucinations or from other kinds of errors in the responses. There's a lot of different kinds of tweaking that you have to do, and you have to be thinking about, just because everybody else was happy with that model doesn't mean that you can just turn it on in prod and have a good day. You need to be doing the same kind of experimentation, the same kind of adjustments as you roll out each model that you did with the prompt, that you did with your code. And doing the same thing as well, both from the initial stages of experimentation all the way through to the canary out to your own dog food. And I mentioned it as well, but when you do those switching, it can be a pretty major event, right? So it's not sort of like, oh, this week we were on model 1 and next week we're on model 2. Switching from one model to the next was something that we had to plan for. We had to plan for it in terms of compute. We had to plan for it in terms of lots of modifications to the system. It's more like hey, we're going to switch, and it's going to take us a couple months. It's almost like a re-architecture. I think that's really, because it's just a string that changed, right? But honestly, it's like switching the underlying database or switching the underlying architecture of your system. It's that scale of change in our experience, and you should just plan for it in that way. All right, I am at just about 10 minutes to go, and I wanted to remain some time for questions. I have a few more slides here. Oh, that's the other piece. They're more expensive oftentimes. I had a few more slides here, but I think I'm going to go through them real quick in the interest of time. I'll just talk. I'll do this, and then I'll talk the last thing. The last thing that I found really super interesting as we started doing AI inside of a large organization is that all of the observability stuff that we were doing for understanding if our system was okay turned out to also be crucially important for managing an AI Copilot system in a large organization. And the reason for that is in any large organization, there's a lot of different product owners. So I can give you an example of a prompt. If I walk up to the Azure Copilot and I say, how do I back up my database? Is that a prompt for the database team to handle? Or is that a prompt for the backup team to handle? Because, by the way, there's a SQL team and there's a backup team. And the way, I didn't get into the details, but the way that the Copilot is built, there's the ability for each team to contribute their own handler, their own specialized prompt that knows how to talk about BCDR or that knows how to talk about SQL and databases. And it turns out both teams are going to want to answer that question, answer that prompt. And you can look at agentic approaches to blend those answers together, but especially early on, we just chose one handler and went with it. And then teams would get very upset. And they'd say, like, why didn't you ever choose my handler? Why do you hate us and love the backup team so much? And being able to have that kind of observability and say, actually, no, like, we didn't write magic code that like elevates their handler and votes down your handler. Here's how we're looking at the system. Here's how we're understanding how things are performing. And here's how we're making these decisions. Really helped diffuse a bunch of the conversations that we had that would have otherwise been really very much just sort of like people yelling at each other. Being able to ground in that data around why we would choose one handler over the other handler enabled us to build a better product, but it also enabled us to encourage each team and explain to each team, who are, again, not AI people themselves, how they could do a better job contributing to the broader platform, which is the Azure Copilot, because we can't build something that knows about every single one of their specific products. And to date, I think we have, order 100 handlers, something like that, for all of the different products across Azure, and bringing them all together to combine into the various responses that you see to the prompts that users input. And of course, it provides a seamless experience when you're there as an end user. It's a lot more distributed behind the scenes. So I think I'm going to conclude there. Thank you so much for listening. I'll be around later. We're having an AMA session later on, so please feel free to bring the questions there. And I think we have a little bit of time for questions right now as well. So thank you.